Hey guys, today we're going to be talking about solving cube root equations. So cube root equations, as you might imagine, are the opposite or the inverse of cubic equations. And so we solve it in a very similar way. Just like the inverse operation of cubing is cube rooting, the inverse operation of cube rooting is cubing. So we follow three very simple steps. Step number one, isolate the radical term. Isolate the radical term. That just means get your cube root by itself. So take a look here. This cube root's already by itself. So next, to get rid of this cube root, we need to raise both sides to the power of the index. It makes me sound like a mad scientist. Well, I'm the next best thing. I am a math teacher. So we're going to raise both sides to the power of the index. So I'm going to raise this side and this side to the power of 3. My index is this little tiny 3 right there. And so we raise to cancel out that cube root, we're going to cube it. So we're going to be left with 7x minus 15, 5 cubed. Now, 5 cubed is 125. So now we're just going to solve for that x. To solve for that x, I'm going to have to go through the steps here. I'm going to add 15 to this side, add 15 to this side. We're going to get 7x equals 125 plus 15 is 140. Then we will, of course, divide both sides by 7, and we will get x equals 140 divided by 7 is, of course, 20. So there's my answer, x equals 20. So that's all you have to do. Get your cubic by itself, get your cube root by itself, raise both sides to the power of 3 to cancel it out, and then solve for x if there was an equation still inside there. Okay? All right. Our next one here, we have 7 plus 4 cube roots of x equals 3. So we're going to go through the steps again here. We're going to start off, we're going to minus 7 to both sides. That's going to give me 4 cube roots of x equals 3 minus 4 is, minus 7 is negative 4. And then we're going to divide both sides by 4. That's going to give me the cube root of x equals negative 1. And then I finally have my cube root isolated, so we're going to raise to the power of the index. So I'm going to raise this side to the power of 3 and raise this side to the power of 3. So I'm going to get x equals negative 1 cubed is negative 1. Okay, it's not like squaring. Squaring takes away the negative, but cubing leaves negative. See, look, we go negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is positive, but a positive times a negative on the end gets me back to negative. So we're going to have x equals negative 1 as my answer. All right, let's take a look here at number 3. So number 3, we have a cubic here and another cube root here. Well, we're going to start off, I'm going to add that other cube root to the other side. Okay, because we want to get them both isolated if we can. So I'm going to have the cube root of 2x plus 5 equals the cube root of x plus 7. Then we can cancel both of these cube roots out at the exact same time. I can raise this side to the power of 3, and I can raise this side to the power of 3. So I'm going to have 2x plus 5 equals x plus 7, and then it's a very simple solve. Then all I need to do is minus x here, minus x here. Minus 5 here, minus 5 here. 2x minus x is 1x. 5 minus 5 is 0, x minus x is 0, and 7 minus 5 is 2. So I get my answer there of x equals 2. Okay, let's work with isolating with a fraction. Sounds fun. All right, so we're going to need to get this cube root by itself first. Isolate it. Isolate it first. So we're going to start off, I'm going to add 1 to this side, add 1 to this side. So that'll give me 1/2 times the cube root of 6 minus 3x equals 1. Then, remember, to get rid of a fraction, we're going to multiply by the denominator, multiply by the bottom. So I'm going to multiply this side by 2. I'm going to multiply this side by 2. So I'm going to get the cube root of 6 minus 3x, because this 2 and that 1/2 will cancel out. If you have 2 halves, it makes 1 whole. And so we're going to have 1 times 2 is 2. Now, raise to the power of the index to get rid of this. 2 cubed is 8. So we're going to have 6 minus 3x equals 8. So our last 2 steps here is I'm going to minus 6 to both sides, get negative 3x equals 2. And then I'm going to divide both sides by negative 3. And we're going to get x equals, these will cancel, so I have x equals negative 2/3 as our final answer there. Okay? All right, going pretty quick now. Let's try number 5. So number 5, we have the cube root of 3x minus 10 squared plus 1 equals 5. Whoa, whoa, whoa. We have a quadratic hidden inside of a cube root. How is that supposed to work? Well, let me show you. We're going to start off by getting rid of that cube root. And to do that, I need to isolate it. So we're going to have to bring this 1 over to this side first. So we'll have the cube root of 3x minus 10 squared equals 4. Then I will have to cube both sides. Okay, so that'll leave me 3x minus 10 squared equals 4 cubed is 64. If you don't believe me, use your calculator. Then we need to get rid of that squared. To get rid of that squared, well, we have to use the square root method, right? To get rid of that square, we're going to use the square root method. So I'm going to square root this side. Square root are opposites, and we're also going to square root this side. So that'll leave me with 3x minus 10 equals plus or minus the square root of 64 is 8. Remember with quadratics that we need to include that plus or minus in our answers. So we're actually going to get 2 solutions for this. We're going to have 3x minus 10 equals positive 8, and 3x minus 10 equals negative 8. And we're going to solve it both ways. So I can add 10 here. That'll give me 3x equals 18. Divide both sides by 3. And I'm going to get x equals 6. So there is one of my answers. Here's my other one. I'm going to add 10 to both sides here. And we're going to get 3x equals negative 8 plus 10 is 2. Then I will again divide by 3, but I'll get a vastly different answer. This time, I'll get x equals 2/3. So like I said, we actually get 2 answers on this problem. We get an x equals 6, and we get an x equals 2/3. Sometimes we have a different type of problem hiding inside of a cube root, okay? But that's okay. We know how to solve quadratics. We just square root it. All right, our last problem here, number 6, reads, the armadillo can jump 3 to 4 feet and grows to about 15 to 23 inches. Good for the armadillo, I guess. From the neck to the base of its tail. Some armadillos roll up into a ball when they are frightened. The spherical shape can be used to show that the function y equals the cube root of 6 pi squared x relates the length of the y of the armadillo in inches to its volume x. Suppose you measure the length of an armadillo as 18 inches. Find the volume of the armadillo to the nearest cubic inch. So if my length is 18 inches, that means that my y right here is going to be 18. So we can rewrite my equation as x equals 18 equals the cube root of 6 pi squared x. And we're going to be going for the nearest cubic inch. All right, so first thing, isolate my cube root. Well, it's already isolated, so we're going to raise to the power of the index. So I'm going to raise both sides to the power of 3. Now, 18 to the power of 3 is a really big number. Use your calculator for this. Remember, on your calculator, you can pull it up and you can say, okay, 18, and then we have that power button right there. 18 to the power of 3, and it's 5,832. So there you go. We have 5,832 equals 6 pi squared x. Next, we're trying to get that x by itself. So everything that is being multiplied to x, we're going to divide by. So I'm going to divide by 6 pi squared. Once again, this is going to be a great use of our calculator. So I can plug this in. We have 5,832 divided by 6, and here's the tricky part, 6 pi. So to do pi, we've got to go second pi and then squared. So 5,832 divided by 6 pi squared, it's going to be, make sure you put parentheses, folks. This is important. So we're going to go back again. 5,832 divided by parentheses 6 pi squared. All right. Man, I'm telling you, parentheses, parentheses, parentheses. This number doesn't make any sense at all. So we're going to hit enter again, and that makes a lot more sense. That is a much more reasonable volume for an armadillo. Could you imagine an armadillo with that big of a volume? It'd be gigantic. Anyways, there's our answer, 98.48. So the nearest cubic inch is going to be 98 inches cubed. That's going to be our answer for the volume of that armadillo. All right, guys, hopefully this video has been of help to you, and I hope you have a great rest of your day.